Well, I want to welcome everyone to Professional Dehumidification Strategies for High Performance Homes. I'm really excited about this session because we know we can use dehumidification to meet sustainability standards, to keep people comfortable, to keep people healthy and safe in new and existing housing, and perhaps, play a role in energy conservation to some regard. So that's one reason that it's very important to us to get the word out about this. And as far as the time of this recording, it's starting to get humid out there, and in many places already is. So perfect timing to think about this. This particular course is brought to you by the GreenHome Institute. The GreenHome Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the places we live. Today, I will be your moderator. My name is Brett Little, and I am the program manager here at the GreenHome Institute. As always, these courses are approved for multiple continuing education units, as well as pending LEED v4.1 residential single family LEED APH CEUs, as well as our certified green home professional designation, health and energy, and AIA, health, welfare, and safety, which may make it applicable to your state-based design or contractor license. If you haven't become a member yet, I think we still got a couple of these mugs left. They're made in the USA. They're made out of corn. And thanks to our sponsor, our board member, True Tech Tools, for funding those. We've got a couple left with your name on it. We'll send it your way. You'll get instant access to all of these sessions, no registration, as well as our recorded sessions, and as well as discounts and free green certification, such as our Green Star program. And first, we have to say a huge thanks to one of our top tier sponsors, April Air. April Air has everything you need for a healthy home air system. One thing to think about in that is radon, something I learned recently that April Air can help you with. Radon mitigation, very important, often gets left out, especially if you're not in EPA radon zone. I believe it's 1. They're 1 through 3, 3 being not so bad, 1 being the worst. And so even in those zones, radon can be a problem. We've seen it in our testing. And so make sure you're getting homes that you're working in tested for radon. If you're building new, just put the system in right away. Just put it in, and then it's not a problem. So you can check that out over at April Air's website to learn more about their radon mitigation system. And then their, healthier home systems, humidity control, temperature control, air purity. One thing I appreciate is the water efficient humidification process for in the wintertime when we need to humidify, which is a win for health, water conservation. And then we're talking about energy efficient dehumidification paired with a right-sized heat pump can keep the air feeling cool and perhaps allow for higher set points. And then we're talking about MERV 13 filtration, which captures particulates of growing concern, such as airborne viruses, PM 2.5, which can come from wildfire smoke. We're seeing more of VOCs, dust, and more. So check it out over at www.aprilair.com. And our second tier sponsor, Aware, how do you know these problems are even occurring in homes to even need to know to fix them? And that's really where Aware comes in. We're talking about an air quality monitor that tracks 5 key indoor air quality metrics down to the 5-minute interval. They're tracking temperature, humidity, CO2, TVOC, and PM 2.5. And so total volatile organic compounds, they can come from anywhere. I learned recently that burning certain types of candles we had put off way more VOCs than others. So we're not using those anymore. CO2, right? If you're working from home a lot or you're even in the office, too much of it can make you tired, sleepy, irritable, and yet at the same time, it can ruin sleep. And so we want to get CO2 levels down. Humidity, which also includes reports of a dew point reminder, so you can see just how bad that humidity is in junction with the temperature. They're giving you that data. And then lastly, temperature. Yes, we all have thermostats, but one thing that I've recently learned in my own house using Aware is that because of the way the duct system is set up, an older duct system, part of the home is warmer, part of the home is colder when you don't need it to be. So it's giving me that information, very helpful to see. You can track this data in real time. You can see when spikes are occurring throughout the day in certain pollutants, so you can see what is happening to fix it. And then you can get data over time, over the course of several weeks to see what issues are occurring and come up with a plan to solve it by being informed. So Aware has an integrated sensor that can be placed on the wall as well, or a standalone system. So, and the integrated ones can look at noise and light as well. So you can check them out over at aware.com. Before we get into today's session, one thing that's important to know when it comes to dehumidification is that I think the Lead for Home single family version v4.1 is really the only one that recognizes the need for dehumidification and rewards for it. Some of the other ratings systems do require tracking of real-time humidity, which is important, but this one actually gets into rewarding credits for systems in place to make sure these problems don't occur. So the first area is in the indoor environmental quality section under the balancing of the heating and cooling distribution systems. There's an option 4 there called moisture load control. So you're talking about installing systems that can maintain levels at or below 60% relative humidity. So these may be additional dehumidification systems, not standalones, or a central system equipped with an additional control. So that's another way to get a point in the LEED system. And then there's also under the enhanced ventilation system, so you're talking about balanced ventilation, there is an extra credit for a whole house ventilating dehumidifier, an additional point there. So if you can do both, where you have this enhanced ventilation and you have control, you can keep it under 60%, there's 2 additional points for your single family V4.1 projects right there. And that's what we're going to talk about, the technology behind, how to achieve that today. And then our just recently launched our Green Star Homes certification program. At the platinum level, we are requiring humidity control per climate zone appropriate. So being able to both humidify and dehumidify as needed as a requirement for the project, again, based on the climate. And so even looking at the swing season. So these types of technologies we're going to be talking about today are very important to achieve the platinum level of Green Star if you want to get to that high level. So with that, I am going to turn it over to Chris Howells from April Air to be leading you through this session today, and then we'll circle back for Q&A. And Chris, excited to have you. Welcome back. This is your second time on our show, so good to see you, and please do take it away.
Great. Well, thank you. It's glad to be back. Thanks for welcoming me back. Yeah, you laid it up really nicely here in a lot of discussions of, specifically to the indoor air quality environment of the homes, dehumidification specifically. So we've got a lot of information for you. So I'm going to jump right in. And as Brett alluded to, if we have not met before, my name is Chris Howells. I'm one of the training managers here at April Air. And really just to kind of paraphrase my career, it's been in this industry my whole life. My grandfather owned his own air conditioning business in Dallas, Texas. And when I was 10 years old, I started with him, and it's accelerated my career to where I'm at today. Just love the opportunity to be able to educate, to talk about not only the heating and air conditioning side, but this complete environment. And dehumidification is such an important, but sometimes overlooked attribute to a home. We're grateful. Thank you again, Brett, for this chance. And thank you all for taking the time out of your day today to go through this. And, this is how we all get better. We learn from each other. We take this, we apply it, ask the right questions. We'll dig deep into this. And we're going to give you a lot of information, as I mentioned earlier. So I want to start with this in asking you, kind of in a rhetorical way right now, what is indoor air quality to you? And you start to look at some of the words on the screen there, and maybe a couple of them are jumping out to you, and you go, you know what? When I think about indoor air quality, I think about that specific problem. Maybe it's mold. We're talking about dehumidification. Maybe mold is popping into our minds, or that dryer that Brett referenced earlier, that leads into a humidification. So if we really look at these words, there's 2 parts to indoor air quality. There's your problems, and then there's the solutions. But first, what I want us to really dig in and try to understand is we can't just focus in on one of those words, whether it's a problem or solution. We have to look at the holistic approach to indoor air quality. And that's what IEQ is. IEQ is temperature plus the humidity control, plus your high efficient filtration, plus your ventilation, plus, as Brett mentioned at the beginning, radon, such an important part to the indoor environment that we're all living in. And with all of these put together, this gives us that complete opportunity to build this environment inside our homes. And if you're building more efficient, tighter homes today, what I absolutely love, aside from that alone, is you now have complete control of that environment. But you got to have the right systems, you got to have the right controls, you got to have the right measurements, and be able to dig into what we're trying to accomplish. Just taking a quick look back in our rear view mirror, not to spend a lot of time on this, but during the pandemic season, indoor air quality, the industry, saw a huge market surge. And we can break that down any way we want to. But ultimately, at the end of this, what did we see and what did we continue to see be brought to the forefront in our industry is that now we are all more healthy air aware. We're driven towards understanding now this environment that we live in, that we breathe, that we can control this. And we've got great systems out there that we can apply to our homes and to our buildings and build this healthier environment. And this really goes way back. This is nothing new. This goes back to a study in what ASHRAE partnered with the CDC did back in 2005, where they were studying buildings and homes and how do we minimize spreading infectious diseases, colds and flus, upper respiratory infections, any of those types of things. And we really need to understand that it gets down to one specific statement. We cannot focus on one specific attribute to be able to say, here is the strategy that will take care of all your indoor air quality problems. Just do this and you're good. It's a multi-pronged solution of three things. You have to provide the fresh air ventilation, you have to filter at a high efficiency rate, and you got to control the moisture. If we do those three things, we are building up the best defense against that unhealthy, sick, polluted air in our homes. Now, this isn't the conversation today to get into, but we will talk about it a little bit. Ventilation alone is the best single pronged solution if we are trying to minimize that infectious diseases. I mentioned defense. I love this analogy. I'm a sports guy. I hope maybe some of you are as well. And when we think about a defensive scheme and trying to minimize the offense from scoring, in this case, the offense is our unhealthy, sick air. And we need the best defense to come together at the same time, working together to stop that offense from scoring. The offense is trying to affect us, and in some cases, infect us. When we look at a defensive strategy, going back to what ASHRAE stated, we need that multi-pronged approach to it. So if I was to analogize your defensive line being your fresh air ventilation, that they're providing that dilution of the VOCs, of carbon dioxide levels. We're getting specific air changes per hour, and it's controlled, filtered, and conditioned properly, your best defense against that unhealthy, sick air. But think about how many homes that we go in that don't have that proper defensive line. So their defense is already broken down. Secondly, we've got linebackers and corners, which is our high efficient filtration systems. MERV 13 is great. MERV 16 is even better. We want to capture all of those very small microscopic particulates that float through our air, that get moved through our HVAC system, where we have every opportunity to capture it. Minimizes those virus spreadings. In some cases, can even reduce odors. So now we've got a good, strong defensive line. We have a great linebacker and good corners. We just need our secondary, our safety to step up here. And that's controlling the moisture, both in humidification in some parts of the United States and dehumidification in other parts. And then a lot of us, I saw a few chats there in Chicago. Boy, Chicago, you need both of these humidity control strategies. And this is going to manage the survival of those poor IQ conditions. We're going to show you a chart that shows when we have a specific relative humidity range, there's specific indoor air quality triggers that thrive when those humidity levels are both very low and very high. So as I said, if we have a complete defense that's working together, they're going to create a healthier indoor environment. Now, in thinking since the last time I had joined you all and looking through the problem of what Brett alluded to at the beginning of how do we know if we have indoor air quality problems? Well, we have to be able to sense and be able to get into more of those measurements and diagnoses. But if I was to show you a glass of water and say, you have an option, which glass of water would you choose to drink? Would you drink the clean glass of water, or would you drink the dirty glass? And I'm sure every one of us, given the choice, would choose that clean glass of water. And if I just flip the verbiage really quick and say, okay, those dirty glasses of water, or excuse me, those glasses of water represent the quality of air that we all breathe every day, which one would you choose then? I'm sure we would want to choose the clean air, but many of us are stuck in that dirty air glass. Looking at the environment of the home, it's very complex. And this is that building science side that we could probably spend the next 60 minutes just talking about this slide alone. But when we take our environment and we're controlling it, we're giving it all those key elements to a more energy green built home, we still have to consider all the potential pollutants and unhealthy elements that are existing in our home. You've got pet dander if you have pets, carbon dioxide, as I mentioned, bacteria. Up in the upper left corner, you see all those little chemical symbols. Those are VOCs, volatile organic compounds. And many of those survive and thrive in humidity-related environments. You've got mold spores, pollen, viruses, particulate matter, actual water molecules, radon gas. Again, as I mentioned, we live in one big science experiment. It's kind of crazy when we start to drill it down and drive it to what are we accomplishing in this home and how they all interact based on temperature, based on moisture levels is somewhat interesting. But we're missing the key part to our indoor environment, and it's us. It's the occupants of the space that we have to think about and consider to this environment that they live in or that we live in, and that quality of air that we're providing to them. The question of, are indoor air quality problems hard to identify? Can we see specific things or feel specific things in a home or a building and know that we have an indoor air quality problem? I would all bet we'd shake our head yes right now. But how do we go and make this unseen seen? We can't see a lot of these components that we've talked about. And that's why I love this industry, the heating and air conditioning industry. We see a lot of this. Unfortunately, we miss a lot of this. I'm going to show you some pictures here that I've either taken from experiences in the field or that I've been shared over the course of the years. And all of these represent poor indoor air quality conditions through our heating and cooling equipment. And if we take these pictures and we start to drill them down a little bit, we have to go, there's a problem. What's the solution? So for instance, you see the picture of that thermostat and you see that the cooling is set to 78 degrees. The indoor temperature is the bigger number, the 75 degrees. But what's even more mind-blowing is that that indoor environment has a 66% relative humidity. Now, I can tell you firsthand that that came from a house I was in Atlanta, Georgia. The air conditioner was running. It was trying to dehumidify by overcooling. But when we get into the thermodynamic side, you will see that not always cooling the air equals effective dehumidification. Now, if we were a group of technicians, that second picture there, that clear trap would represent that clean glass of water or that dirty glass of water. And many of us, if we've seen those, they're dirty, which tells you that the quality of air that's moving through that HVAC system is also dirty. We've got poor filtration, dirty evaporator coils. We start to get warped floors when we have high humidity, dirty blowers, mold or microbial growth, we'll call it that, inside our heating and cooling equipment, which is releasing spores into the air that we're just consuming. Don't even realize it. We start to feel ill, but we don't know what the repercussions are. We just feel we caught a cold or we're just sick at the moment. A lot of it comes from potentially what we have inside our environments in our homes. That little itty bitty portable dehumidifier that you see in that big giant basement, and how effective that is, we'll dive a little bit deeper into that. And then what happens when we start to see that growth occur on drywall or on baseboards? I've seen it on curtains. You can probably even fill in a lot of the gaps that I'm missing there. So we really need to go in and understand controlling the humidity and getting into understanding the thermodynamics and the psychometrics, or the technical side to this quality of air. So breaking it down in its simplest form goes back to way back with John Dalton. Dalton's law of vapor pressure that states that humidity is a water vapor. It's actually lighter than air and rises throughout the homes. And it acts just like a gas. And to the contrary of what many people think, is when you have a lot of moisture in the home, that air becomes very heavy and that moisture falls to the ground. Well, I always like to reference it to a pot of boiling water on the stove. And as you see that steam rising, that steam doesn't rise and then fall back down. It rises and keeps rising until it's 100% absorbed or evaporated into the air. If I even get a little bit more technical with you and show you this psychometric chart, you will see that this kind of breaks down all of the elements to the quality of air. And it represents it to temperature, to humidity, to total BTUs, grains per pound. The list can go on of how we can really depict and know what this chart is telling us. But relative humidity, and why we use that often, is it's really easy to understand, because it's the percentage of the moisture in the air versus how much it can hold at 100%. So I always like to look at Miami, Florida and Phoenix, Arizona, because if they both have the same exact temperature, we would think, hey, it feels very much the same. But we both know, or we all know, that if we've been to both of those places, 92 degrees feels completely different in Miami, Florida than it does in Phoenix, Arizona. And that's breaking it down to adding in that next element of temperature plus humidity. Because at 85% relative humidity and 92 degrees, that equals an 86-degree dew point, or almost 200 grains per pound of moisture. That's a lot of saturation in the air. And our bodies are somewhat evaporative coolers. And if we've got that much moisture in the air, our bodies cannot absorb, or release the moisture fast enough. So we're actually going to feel very uncomfortable. Now, go to Phoenix and take that 92 degrees and put it into 10% relative humidity. You can see our dew point drastically drops to 28 degrees, or only 22 grains per pound. So now that 92 degrees doesn't feel as drastic as it did in Miami, because our bodies are quickly releasing our heat and that moisture, and it's absorbed into the air. High is always going to go to low. So just think of it that way. And those lines that I just put on there, your red is your dry bulb, your blue is your relative humidity, and then your green is your absolute humidity, which we need at least 2 of those measurements to be able to plot. Or with technology today, there are some great apps out there that you don't need to pull out this chart any longer. Just take it and put it into the app and what you're measuring, and it'll give you all that information. Even breaking it down more elementary that I like to do, keep it simple, is the ASHRAE 55 2017 designation of how we feel depending on where we plot on that chart. So same chart as what we previously saw here, but a little bit more dialed down. And we could see that if we're plotting outside of that comfort zone, we're going to start to feel hot or dry or cold or humid. And over on the right-hand side, that actually brings in the metabolic side to how our bodies will be represented based on those similar measurements. So it's pretty fascinating. This is really a part of a course that takes a week long. So I know I'm just kind of giving it a very brief touch of the info that's really available on thermodynamics and psychometrics. But it's very important to understand this relation between temperature and humidity. Because if we simplify it and we say your temperature is the volume of the air. So if we were to use cylinders, for instance, 70-degree cylinder is going to be much larger than a 30-degree cylinder. Then we put the water into that cylinder, we're going to have different percentages of how much volume of that cylinder we're consuming. So that's the relative humidity side. So 70 degrees with 12 grains of moisture is equal to 12% relative humidity. So we're consuming 12% of the total volume of that cylinder with water. If I take the same amount of water and put it into that 30-degree cylinder, you can see my 30-degree cylinder is much smaller. I've consumed 50% of that cylinder. So that's kind of the basics of understanding the relationship. But really, when we get down to controlling the humidity, and that goes back into that attribute of humidity management or humidity control, really in a conditioned environment, the only way that we can control this or manage it is by having systems, either dehumidification systems or humidification systems. Because if all things are equal in our temperature, the only way we can remove moisture or add moisture would be physically by using a mechanical system to do that. Now, there are some natural ways we can do that, but very inconsistent, very labor intensive. The best way to create the environment is using a complete healthy air system to drive to that healthy indoor environment and more comfortable and even a preserved that we'll dig into here. So I mentioned ASHRAE comfort charts. So on the left-hand side there, you can see you have your poor indoor air quality conditions, like bacteria, the viruses. You get into specific growth potential, dust mites. We'll talk a little bit about those, but you can see the list goes on. ASHRAE is stating that the healthy zone is 40 to 60%. That's where we should keep our indoor environment, is between 40 and 60% relative humidity. But you can see I have the highlighted line in the middle there. 50% relative humidity is the best overall to minimize as much of those poor indoor air quality triggers as possible. But that's a little subjective. It's very difficult to achieve 50% consistently year-round in every climate, in every region. Because if it's 10 degrees, say, in the most northern part of Minnesota, I don't want you to have 50% relative humidity. You're going to have all kinds of indoor problems with condensation on windows and in other areas. And the same thing if I think I saw a few folks from Florida. Think about trying to truly maintain a 50% relative humidity or less throughout the summer months. It's very difficult to accomplish. But knowing what the industry is telling us is the best is what we should strive to. Now, we as a manufacturer, we recommend 45 to 55% in the summer because that gives us a good range based on those climates, based on those regions, partnered with your heating and cooling equipment to get you into that healthy zone. Where does this moisture come from? Well, a lot of it is around us. If you're in an area that has a basement, a crawl space, and even so some sort of slab, they're not 100% vapor proof. And with moisture being an element of vapor, we can get that moisture coming in from the lowest point and rising through the homes. So our basements are often the culprit. Our crawl spaces are very much a culprit unless it's properly encapsulated and conditioned. The slabs are the most difficult because we need the room to be able to do that, or your attic application. So we need to think in controlling humidity, especially high humidity, and attacking it at its lowest point, which is in the basement or the crawl space. You maybe either have experienced one of those pictures on the screen, or maybe you currently are in one of those scenarios on the screen where you have a block foundation wall that has moisture that's coming through. You know, those blocks are like giant sponges. If we've got the moisture on the outside, it's going to suck it in. Plus the vapor pressure is pushing it in. Plus the dynamic of humid wants to go to dry. And even though that the basement might not be very dry, the differential, the higher is going to the lower, it's actually just pushing it right in. Now, I would say that there's probably a bigger problem in that picture on the left than just stating, hey, we need to add a dehumidification system. We really need to take it a step back and look at our foundation issues. But you can understand where we're going to in what's leading to that high humidity. How about the basement on the right? People spend tens of thousands of dollars to create this beautiful basement, this beautiful living condition. But when we go into it, it's often cold, it's damp. You even get a little bit of that musty smell. And that all comes from that moisture and that relation of temperature and humidity. The stack effect holds true to our homes, that humid air is going to be at the lowest point and it's going to rise through our homes. So if we're attacking that moisture at our lowest potential level, we're going to do a very effective job at minimizing that humidity that's rising through our homes. And the impact that moisture has on the home, high humidity specifically, is it adds to the expansion and contraction of our home. Our home is built a very, I don't know the specific numbers, but it's a high percentage of wood, which is very hygroscopic. It will absorb and reject moisture like anything. In fact, 1 cubic foot of wood holds 1 pound of water at 60% relative humidity. I was recently in Nashville and I was going through some new construction sites and it had just rained. And all of that moisture was put inside that home and it was in the phase of rough-in. So all that moisture is going to, unless they tore out the wood, which I don't know if they did or they didn't, but that moisture is now going to be trapped inside that home. And if it's a tighter green built home, that moisture is going to be trapped. And if we rely on our air conditioning systems to hopefully dehumidify that, we're probably going to be in for some hurt of not seeing the results that we should have, which is going to lead to uncomfortable, unhealthy conditions. We've seen humidity management have to be held at a specific level in art galleries. Has to be humidity controlled. You go up into an attic and you start to see that black glaze all over the sheathing. You've got some serious problems there. Pianos, instruments that are specific to a relative humidity percentage, mold spores that start to spread, as I mentioned earlier. There's a lot that goes into this that we can all be facing, and it's just because of high humidity. Now, moisture also provides an avenue of survival for many pests and insects. And when you look at some of the insects that are on the screen there with spiders and these other things that love that cold, damp, dark area, they thrive. If I specifically talk to a dust mite for a second there, there's about 40,000 dust mites in just 1 ounce of dirt. Dust mites are also one of the leading causes for allergies and asthma problems for those sufferers. And it's not really so much the dust mite, it's the feces that it creates. So a dust mite is a carnivore, it eats meat, it survives off of whatever it can in that process, but it can't physically drink water. So it survives based on the vapor pressure and the humidity that's in the air to be absorbed into its body. So 50% is the magic number. If we can keep 50% relative humidity or less in that home, dust mites cannot survive. They will either die or they will become dormant. Also, leading back into those other pests and insects that you see there, they will also not be able to survive because very similarly, they rely on the vapor pressure. And some of them eat each other. So it's kind of crazy in this vicious cycle of humidity that can thrive in our own homes. What other sources are there for added humidity to a home? Well, like I mentioned, we go into a basement, the volume of air, it's a lower temperature. We go into a crawl space, like you see in the bottom right corner, it's often cool and damp. In fact, my next slide will talk specifically to crawl spaces. I've seen these little dryer vent thingies there that's supposed to recirculate the heat and not lose the heat. They create more problems than I've seen. I've pulled dryers off the wall and I've seen that whole back wall just coated in mold growth because of how high the humidity was and the lack of air movement behind it. Brett, you got a question, bud?
You know, I've never seen a capturing dryer. That's a bit crazy. I almost just on the first look, it's just like, no, you know, that's my first thought. But yeah. What about condensing or heat pump dryers? Do you see those playing a concern in humidity or not?
Yeah, anything that, and think about the concept for a second. You know, you're taking heat that's being generated and you're exhausting 100% of it outside the home. And somebody somewhere probably looks at that and says, hey, why don't we try to capture some of that heat? The problem is the moisture that we're drawing out is such at an extreme level in that specific application that I'm showing you there. It really, it comes down to two things. It's air movement and the amount of humidity in such a small area. So depending on the other devices that could be capturing that heat or that humidity, it could be a same ramification that as what you see on the screen.
Thanks.
Yeah, no problem. I've been in homes too where people hang their clothes up to dry in the basement. Well, that's obviously absorbing into the air, could be creating high humidity. I do want to touch on that picture that's in the upper right. If you have a lot of walk-in basements, a walk-in basement is fantastic, or a walk-out, however you want to define it. But I've seen it where when we get a heavy rain or that snow, all that water just cascades right down that steps. And depending on the amount of water and the size of the drain, some of that doesn't even make it into the drain. It actually starts to force into the house. That pressure differential will start to force that moisture into the house. And I had one in Lexington, Kentucky, and that was exactly it. It didn't matter how many dehumidifiers that we put in this house. The problem was the amount of moisture that was entering that house. And then obviously cooking, bathing, things that we do individually as humans that can add a lot of moisture to the air. So as I mentioned with the crawl spaces specifically, if I took a typical summer day in that Lexington, Kentucky market, the outside conditions being 85 degrees, 51% relative humidity, we might be going, wow, that's a very nice day outside. It's not overly humid, nice dry bulb temperature, but the dew point is 65 degrees. How do we feel in that condition might be a little bit uncomfortable. Taking that aside, if we have an old style crawl space where we have these open vents, that air is being pulled in or drawn into that crawl space and being introduced to a much lower temperature. So we're squeezing that air mass into this cold air. It starts to condense really quickly. And if you take a look at this, if I bring in those conditions, those outdoor conditions into a 68-degree crawl space, I've quickly taken my humidity up to 90%. The dew point didn't change, but now if I look at that equilibrium moisture content chart that's in the middle of the screen there, it could take just quickly 4 days if I maintain that same measurement to start to risk for mold growth. So this gets back into the encapsulation, conditioning, sealing our indoor environment away from the outdoor. That way we can have complete control of it. But here's where our focus is. Our focus continues to be on our HVAC equipment. We feel that, hey, and no disrespect to any of the equipment manufacturers, there's a lot of great high-end, energy efficient, modulating, multi-staged equipment that can do a fairly good job. But unfortunately, we still get a lot of calls saying, hey, I've got that high-end system and it's just not achieving what I need it to be for my comfort, the health, or in some cases, the preservation. So the typical homeowner will go and just continue to turn their thermostat down to try to offset that moisture feeling problem. And as I mentioned, the problem becomes, number one, we're outside of our design parameters, which is our manual J calculations. So now the air conditioner may not even work to the way it was designed to. And then secondly, we're offsetting one problem and creating another problem. So we have to start looking outside of just the equipment. I've seen this and I've lived this for many years now here with April Air, is we've got mechanical ventilation systems. Well, I'm in a climate, Chris, where it's hot and humid outside. I don't want to be bringing in any of that. Who cares what the code state? No, come on. We've got to understand all of the dynamics and how we provide the best solution, the best strategies that will equal healthier, more comfortable and preserved indoor environments, instead of just making a opinion-based decision, which oftentimes that is, by the way. All right, I don't want to get over technical on this one for you, but I do want to show you, maybe you're kind of like, Chris, yeah, you know what, our air conditioners do a fairly good job. And I'm not saying they don't, but here is a breakdown of a major equipment manufacturer's service manual. We have what's called sensible BTUs and latent BTUs. So you have total BTUs of that air conditioner. So if I was to reference a 3-ton system, that's 36,000 BTUs. A part of that is going to be sensible, which is our temperature change, which is cooling. And there's going to be a percentage that's latent, which is moisture change or moisture removal. So I'm using a 3-ton analogy here. If I take this chart and I see that it's an 85-degree outdoor day, I've got 400 CFM per ton, so 1,200 CFM, that's in the far left column. What this manufacturer is telling me is, if my cursor shows up for you all here, what they recommend, that's what these two crosses mean here. What they're recommending is that the indoor design condition should be 63 degrees of wet bulb, entering wet bulb. If that holds true, then this system, the way it's designed, installed, and commissioned, will deliver a 79, we'll call it 79% sensible ratio, which means 79% of that evaporator coil or that cooling coil is doing its job in just cooling the air. But that just means that 21% of that coil is actually used for dehumidification. Not a great dehumidification strategy. An air conditioner is designed to cool the air, not to remove moisture. Now we can use these charts and try to get as close as we can. But when I was looking at this chart and utilizing this in our training platforms, something else just completely jumped out to me. And if I reference back to that entering wet bulb column, if I lower the moisture content in my home, so my entering wet bulb condition is lower at 57 degrees, my air conditioner is 100% sensible, which means every BTU that's coming out of that air conditioner is used to cool my house. That means something else has to dehumidify. And that's when we're going to get into the professional dehumidification systems as the perfect partner in working with your heating and cooling equipment, or excuse me, your cooling equipment, to create this healthy, maintained, and controlled environment.
I'm on mute. Can you repeat that just so I heard it right? When when ACs, or ideally heat pumps, are right-sized, they're spending their time cooling and can't really get to the dehumidification. Is that, or fully to it? Yeah.
That's a good way to phrase it. But yeah, just to repeat it. So here is what the manufacturer is stating. They're stating at this design parameter at 63 degree, entering wet bulb, which by the way, if I had it on the bottom here, would say 75 degrees and 50% relative humidity. That's what it would tell you. That this total BTU capacity is 34,540 BTUs. 27,220 of those BTUs are just changing temperature. So that is cooling the air. The rest of the BTUs is trying to remove moisture. If we have an ancillary system that can remove the moisture, my air conditioner is going to be able to do a much more effective job at lowering that temperature.
Mm-hmm. Cool. Thanks for clarifying it.
Absolutely. But this is what we see. We see this all the time. Customers do this all the time. I'll just go buy one of these, and they'll go buy a portable dehumidifier from either online or a major retailer. And I can understand the thought behind it, but we have to truly know what we're trying to accomplish for the area that we're living in. Most of our homes are not able to be dehumidified by these small portable units. Now, they all have ratings, they all have specific standards that they have to meet to be able to market them and to be able to categorize them. However, there's not a lot of detail into the sizing in what they provide to equal the result that's expected to create that healthier environment. So be cautious if this is something that you're looking at, or maybe even you have one. Is it meeting the expectation of maintaining that humidity level that's acceptable through the whole house? They're really good in a small area. They really are. But when we start to get to that more whole home, or trying to achieve a better baseline for humidity control, these products are just not the answer. Just from a safety standpoint, we want to make sure that we're providing the best information possible to you for your knowledge to be able to take out to others. There is still one of the largest appliance recalls that is re-upped every year, and it's based on portable dehumidifiers. And this was a new one just as last year through the Consumer Reports. This is secondary to another one that's been existing since 2007, where other manufacturers of foreign-made portable units are still experiencing failures. I'm not going to get into the details or go through it, but I would encourage you that if you have a portable dehumidifier, it would be worth your time to go take a picture of the data plate and just go to in Google search, put in portable dehumidifier recalls, and get the information for yourself and dig in and make the best decision possible. There's a lot of problems and some serious issues that could be had with these products, not only from their lack of ability to truly dehumidify. Now, we work at Aprilaire, we work with a lot of contractors throughout the United States, and a lot of them make the right recommendation to builders and to consumers. But there always becomes that sticker shock, because I showed you $279, and I think the one online was $134. I see on average a professional dehumidification system being recommended for $2,500. And it's sticker shock. It's instance, oh my gosh, I'll go buy 10 of those other units and still be ahead of the game at the end of the day. Well, like for dollar, sure, you would be. But from the performance standpoint, the safety and reliability, but let's think about that environment that we're trying to create, that more conditioned environment. So what is the value of the price? Because if that's all we're hanging our hats on, then we've got to consider the value that's there. It's much more than a dehumidifier. Professional dehumidification systems are not portable dehumidifiers. You got to consider all of these solutions and problems that it solves. That's going to value and impact not only the comfort and preservation of your home, but the potential health attributes that it's going to bring to a family that's living there, that's experiencing this problem. There's a lot more to it. And I know I've kind of baselined it. We're going to get a little bit more detailed here. specifically on the next slide. In comparing them, there is no comparison between a portable and a professional dehumidification system. They are not equal to one another. I have a side-by-side chart there that shows a portable dehumidifier versus a professional dehumidification system. And the key point to that chart, there's a lot of good information there, is really about halfway down. And it boils down to airflow. Airflow is what drives efficiency, what drives air changes, what drives comfort. A portable dehumidifier on average is around 40 cubic feet per minute. So 40 CFMs are moving through that portable dehumidifier. A professional level dehumidification system typically moves 4.5 to 7 times that air. So just in thinking about airflow alone and the results in getting that cubic feet per minute and how many hours a day it's running, you're going to get a much better humidity control result with more airflow movement, more capacity removal. You don't need to empty buckets. These systems have drains that are attached to them. There's cycle flexibility on, we want to maximize performance versus that portable dehumidifier that just keeps chugging along, keeps going and going and going, never shuts off. And that's what, by the way, creates the recall, is they end up catching on fire because they overheat. Professional dehumidifiers don't do that. They have a much more strategic control logic to them. In speaking more to the airflow conversation, just really quickly, if I was to take that 100 pint per day dehumidifier system on the right, I would just to meet the airflow requirements. That's it. Just to move the same amount of air, I would need 7 of those portable dehumidifiers to equal the airflow. Well, from a cost perspective, as I said, yeah, I'm going to be about $800 ahead of the curve. But then I start thinking about the electrical consumption. Each unit draws approximately 6 amps. Well, so does that professional unit, and I'm only having to power it once. I don't have to power 7 units. So I can really break it down, and I did on another slide. I'll tell you, the savings just like for like, if they were to operate like for like, the dehumidification system on the right would save you approximately $182 a month just in power consumption, like for like as you see it on the screen. So think about the gap that we just bridged between the cost of a portable dehumidifier to equal the performance of a professional dehumidification system. Now here, this is some great facts that we can really start to think about potential energy savings as well in working with our air conditioner, because the EPA has stated for every 4% of relative humidity that we go up or down, us as humans feel about a 1 degree temperature change. So if we take that and move on to step 2, 1 degree equals about a 4% savings from our thermostats and our equipment, our air conditioners specifically. If we play this out again in step 3, if I'm able to lower the relative humidity in a house to 20%, that's equal to 5 degrees is what I feel. That means I've got a 20% potential savings for that month alone if that was to hold true. Now, this is an interesting discussion because it is a power consuming device, your professional dehumidifier, as is your central air conditioning system or your ductless split system or whatever else you might have in controlling the conditioning of your home. But when we start to play that temperature versus humidity game, we can shorten the run times of our central or our ductless splits and have this consumption over on the left-hand side here being your professional dehumidification system. And it ends up being a cost savings. Question, Brett?
Muted again. Do you have, is there any, because you said this came from the EPA, do you know if there's any study both qualitative and quantitative in that, do people actually feel or say they feel more comfortable? Because, comfortable is really just about how someone feels in any given moment. And there's all millions of reasons why you're comfortable or not. And I just wonder, and then also I am curious if truly a 5-degree, isn't, equates directly to 20%, or if that has a lot of relative context to it as well. So I just wondered if there was any study to that or how EPA came up with that.
Yeah. Well, number one, you're exactly right. It's definitely a subjective approach, and each one of us is going to feel different. And do I know specifically the study through the EPA? I don't. I've referenced this for many years, even in the field. The way I've always broken it down is we can calculate, we can kind of put a theoretic calculation behind it and what it could look like. Of if we reduce your thermostat, minimize the runtime of your air conditioning system, and then add in the operation of a professional dehumidification system. The problem with that is it's all theory. It's not really true. And what's the moisture content versus how long that dehumidifier is going to really run out of the gate to the performance of having to lower our thermostat? I could speak personally and take it for what it's worth. When prior to having a dehumidification system in our home, we kept our thermostat around 74 degrees. So tried to do our best to keeping it right there. Once we added a dehumidification system, we keep our thermostat at 78 degrees now because we feel just as comfortable at that temperature as we did at 74. In fact, we feel more comfortable because we're not getting that chill, that bone chilling feeling at 74 degrees as you do at 78.
Great. Well, and real quick, since I'm on and we are at the top of the hour, we're going to keep this conversation going. So there's some more to go over, and I want you all to stick around. But for those of you who need to get going and you've been here for the remainder of the session or the entire session, you're good to go for your continuing ed. You're all set. You can head out if you need to go, but we do encourage everyone to stick around. We're going to get to more questions, but otherwise, thanks for those of you who could join us, and take care. So I'll hand it back to you, Chris.
Great. Thank you all. Before you jump off, if you have to, really where we're going to go now is to talk a little bit more about the actual applications. I've got some pictorial diagrams where maybe you're thinking, how do I apply this into a system that is in our region? How do I size a dehumidifier? So things like that. So I hope you can stick around and listen to that. So looking at this dehumidifier sizing guideline, we have to rely on a few different attributes to a home. The first being, where is the home built in regionality in the United States? And then what's the efficiency of the home? Meaning, just in broad terms, is it a loose home? Is it an older built home where there's poor windows and you got a lot of infiltration? Or is it to today's standards where you have a tighter home, foam encapsulated? But the good news is this, here's what I could tell you. At the end of the day, we cannot oversize a dehumidifier. We can undersize it, just like what we talked about with portables, but we can't oversize a dehumidifier. We will just quickly remove more moisture. Then it will shut off. Most of these dehumidification systems, at least I can speak to the Aprilaire brand, we have a test. If it doesn't run in an hour, we're going to turn the fan on and we're going to measure that condition of the air coming in. That way we know, hey, have we done our job? Can we shut off for another hour, save that energy? Or do we have maybe some humidity that's starting to creep up over there? It's getting drawn into the unit, and now we go ahead and dehumidify. So I want to make that understood from the get-go. But when you look at this baseline chart, you'll see just different model numbers there that reference specifically how many pints per day that it can remove, but then you see your square footage. But I really want to point you to a bolded area in the middle of the screen, because we've got a fantastic tool that can help you size a dehumidification system for your space or the spaces that you might have in your home. So if you either got a pen and paper, jot that down, watch this back, take a picture with your phone, because that's a great way for you to kind of get that understanding of what size dehumidifier do I need, instead of just going, okay, I'm somewhere in this area here. Because it does take into fact all of those regionalities, takes in size of the family that's there and so forth. So hopefully you got that information. Now, these E-Series dehumidification systems represent an Energy Star Most Efficient 2022 category. So all of these professional dehumidification systems that you see on the screen there are rated to that standard, which means they meet the minimum requirement for Energy Star, but they exceeded at even a higher level. And it's all based on that pint per day, and energy usage breaks down to kilowatts per liter, not to get into that nitty gritty, but that goes back to the airflow. And you might see a portable unit that's rated Energy Star, but remember, that's the minimum. That's the minimum basis. Above and beyond. Stop thinking to the minimum, go higher, raise up. And go and see the value in what these systems are providing to you. There's optional installation accessories, as well as you could see, from hanging kits, condensate pumps, risers to get it up off the floor, things of that nature. So that leads into the discussion of where can we install a dehumidification system? Pretty much anywhere within inside the home. As long as it's inside the home, you probably will be able to install these systems. Whether it's working with your HVAC equipment in your basement, it could be working with your HVAC equipment in the attic. If you've got a closet, if you've got one of those quarter walls that are up in the master bedrooms in some of the old Cape style homes, there's endless opportunities to really get this system installed into a home. I mean, I've even got some people that have come to me that they put them in their garage to dry out either their boats after they go boating for the day, or their keep that humidity level acceptable for their historic cars. So, I mean, it's kind of endless at where you can install these. So just taking a look at some diagrams. We're not going to spend a lot of time in talking about the elbows and all this, but you can see here, this is if you're in the Midwest where you've got your HVAC equipment in the basement, there's usually not a return duct in the basement unless it's been finished and sized accordingly. But a lot of times there was a couple supply ducts that were dumped to just move the air into that basement. Now in the Southeast, that didn't happen. They actually have fully separate conditioning systems for the basements. But for Midwest, if you have this, a great way is just to have that dehumidification system inside that mechanical room or near that furnace area, drawing in the humidity at the lowest point in that basement where it's the highest, distribute it back into the return. And you can see I've got it as high as possible in the return drop. That way we're getting that good blend of air going back through. And then we're not only going to distribute that dry air back through the whole house, but also in a percentage back into the basement. So that's a great way to start with a application in the Midwest. I'll be honest with you, this is probably our most common installation. It is simply freestanding, attacking that moisture. I think I saw, Brett, I know you're up in the Michigan area. I thought I saw another person in Michigan. Boy, talk about some saturated grounds. Attack that moisture in your basement at your lowest level and just freestand it. You'll notice the collars that are on the left and the right side. Those come inside the box and need to be installed. I will always recommend installing those collars because you've got a flat surface that they go on. The dehumidifier will work without those collars, but what those collars do is they give you that round diameter to create more push and pull and vortex the air. So you're going to get a better draw and a better throw when you use those duct collars. So definitely recommend installing duct collars on the dehumidification systems. How about a horizontal application? Attics, crawl spaces, South, Midwest, Kansas, that area there, up in the Pacific Northwest, if near the coastal environments, if you need it. Have the dehumidifier in an area where you can either duct it into the supply. Now, state of Florida, if you're in Florida, you cannot duct an exhaust of your dehumidifier into the return. It has to go to the supply. That's fine, no problem at all. We can definitely accommodate that. And that's a little bit what it would look like there. The rest of us in the United States could choose to put it into the return if we would like to. And that's up to application basis. That's up to the result of the performance of the system in working with your heating and cooling equipment. So you have those options of convertibility from supply or return. And then a dedicated dehumidification system. So we're using the dehumidifier outside of working with our HVAC equipment here. It just becomes its own system. And this is great for, say, a basement that's finished, movie room. We just want to attack that area alone. Or heck, you can even do this into the living space if you've got some specific target areas that you want to attack. Now, I drew this up from a crawl space, a dedicated crawl space system. So if you have a dirt floor crawl space, I would caution you in putting a dehumidifier in there because you'll actually start drawing the moisture through the ground. So I would say once you have a full encapsulation, put your dehumidifier system in that space. But if you have one of these L-shaped ranches or even a very long ranch, I recommend putting some ductwork on it because then you're getting that air movement circulating through that crawl space. If I don't put the duct, it's not required. So don't think that this is 100% what you have to do. But if I take this ductwork off, my area of condition is going to be potentially less than what I'm doing here. You can see I'm pushing the air out and it's cycling back to the dehumidifier here. So just wanted to give you some visualization on that. The opportunity for ventilating and dehumidifying, specifically looking at this climate zone map, that if you're in climate zones 1A, 2A, 3A, I would even push into 4 and 5A, that we have to really consider when we're bringing that outdoor air in to condition it properly. And that might have to be through a dehumidification system. I know in Houston, I know down in Florida, the coastal environments of Louisiana, I could tell you up into even mid to upper Georgia, that ventilating dehumidification systems are really the way now that are being standardizes, even versus ERVs or other mechanical systems. And that's because they're very, very capable of removing the moisture, not only from the home, but also from the outdoor air and distributing that air into our HVAC equipment. So I've got a couple more pictures coming up. So with this one system alone, a ventilating dehumidification system, we're providing two key attributes to that healthier air system. And we do it very simply with the installation of a plenum. The wiring, simplified wiring, control logic built in, so you don't have to get into this complex, over-engineered system. This can be very simply done. In fact, here's that Midwest system, taking that dehumidifier and making it a ventilating dehumidifier with that plenum. And you could see, all I've had to do is add the plenum and add some 6-inch inlet duct. All the control, all the wiring is done through the dehumidifier. And I work with my HVAC equipment. So now I'm adding two main attributes through one system. Those attic and those crawl space applications, no problem at all. We can do the same thing whether you're in that return or in that supply. So again, what we're doing here is we're bringing that fresh outdoor air that might be humid, that might have a lot of moisture content. We're driving it through the dehumidifier. If it needs to be dehumidified, it will dehumidify it. If it doesn't, it just simply shuts the compressor off and you've got a great powered ventilation system. Your controls, I mentioned, you've got an onboard digital control with these systems. Precise measurements, precise knowing of what you're setting your control to. So it could be as simple as that. When you take this thing out of the box, you set it on the floor, you level it up, excuse me, and you'll put the duct collars on, plug it in, and now you're ready to go. You hit the on button, the toggle switch, and you've got your control ready to go. But that doesn't mean that that's the only application for controlling it, because I might be putting this in a crawl space where the homeowner has absolutely no way of ever going into that crawl space. So how do they know if it's truly working? I can add a remote control option. And the remote control right now is a simple 4-wire that communicates between the dehumidifier and that control that can give me the control of the dehumidifier, but still measure the relative humidity in the crawl space. I can also add a external control. So maybe a thermostat. My problem is my humidity in my home, and I want to measure the humidity where my thermostat is. Fantastic. We can upgrade your thermostat to a IEQ smart thermostat that has dehumidification capabilities. All we do is set the dehumidifier to external control, and now we're measuring the humidity on the wall, and we're driving the dehumidifier to the operation of what is needed in the space. So the flexibility that you have in controlling it is all dependent on the expectations and the execution of the installation. Within the units, you have other options. You could see we could spend a lot of time on just the setup alone with the ventilation capabilities. You got ASHRAE 62.2 built into the professional dehumidification system. So you're setting your minutes per hour based on your calculations, and it will do all the work for you. You can also enable or disable your dehumidifier to work with your air conditioner. So you can shut off the dehumidifier when it sees a cooling call, or you can allow them to work together. All application optional based on where you're at. As we're getting close to the end here, the maintenance is simple. You have a MERV 8 washable filter. So 6 months to a year, you'll pull this filter out, you take it outside, hose it down, give it a good washing. Then you can simply just slide it right back in the unit. The good thing is you don't have to wait for it to dry. You're putting it in a dehumidifier, so it'll do the job for you. I often get the question of, can we upgrade the MERV rating of that filter? And our stance on it is no. And here's the reason why. This is a dehumidification system. Its primary job is to dehumidify, remove the moisture from the air to create a more holistic indoor environment. It is not an air cleaning device. The MERV 8 filter does a good enough job to capture those larger particles that are in the air and protect the equipment, the dehumidifier, but also maintain a good velocity of airflow through the unit to maximize that dehumidifier performance. If I put a higher efficiency filter into this, I'm restricting more air, my capacity will go down. If we need to think about cleaning the air, we need to think about upgrading that whole home air filtration system in working in conjunction with this system as well. And the last slide is this. You know, it breaks down kind of those interior components, taking a look underneath the hood, if you want to call it that. If you don't realize that your dehumidifier is an air conditioning system, that's exactly all it is. It's an air conditioning system that is packaged in a very small box. You have the 4 key components to an air conditioning system. The difference is we take your evaporator coil and we piggyback it right on top of the condensing coil. And so what we're doing is almost reheating that air. So we're drying the air and then we're reheating it. We expand that air really quickly. You get really good moisture removal and a good performance of dehumidification and moisture removal. And the warranties, you know, I didn't mention anything about warranties on the portable units. Typically, at most, you'll get 1 year. Most professional level dehumidifiers, including ours, is 5 years. So you've got a much more reliable, long-term product that you can kind of hang your hat on. All right, Brett. Well, let's open it up for some Q&A. I see there's a lot of chats there. So do we have anything specific that you would like to open up the conversations to?
Yeah, there is a lot here, Chris. And before we get to those questions, just real quick as a reminder to everyone, for those of you who want to rewatch or reshare this session, you can check it out on our YouTube channel, hit subscribe, and you'll get instant access as it comes through. For those of you watching this in the future on that recording and you want your Con Ed, make sure to take that test with an 80% passing rate, and you will receive your certificate from whichever platform you're on. And for those of you watching this live right now, go to search or check for your spam for certs@gutenbergcerts.com. Mark that as safe. You'll receive your continuing education unit credits. And yeah, we got a lot of questions. Not sure if we'll get to them all, but as they're coming in, just a real quick thanks to our board of directors, our executive director, Jose Reina, all of our volunteer speakers, and all of our sponsors who allow us to do what we do and to keep these sessions going. Mitsubishi, April Air, Build Equinox, Aware, Indo Window, many of them who support our work and allow us to do this. So I wanted to go back to one thing you were just saying, because you took the question right from me, and I think from a few others, on the filter and can I upgrade the filter? But I wanted to expand that question a little bit more, because I saw in some instances you showed that the ventilating dehumidifier was added in the return and sometimes in the supply. And so obviously in the return side, I think of the concern about pulling in PM 2.5 when there's an outdoor air occurrence, which we can anticipate to occur more. And so having that beefier MERV 13 or 16 is probably going to help. But is there a downside to having all this filtration when you're trying to bring in that fresh dehumidified air? Because if not, why not just put it in the return and not put it in the supply?
Yeah, that's a really good point, Brett, of the conversation oriented around maximizing the performance of the dehumidifier with the ventilating sequence in airflow, because there's definitely an opportunity to increase the MERV rating on the dehumidifier side. So that way, if we do whatever contaminants that we could potentially have outside that's coming in, capture them there. And the debate that might become would be, is it more important to capture it through the dehumidifier or utilize the return in the high efficient filtration system, or get it into the dehumidifier system? And in some instances, we don't have that option, because if we're dumping it in the supply, we're going to have to filter better on the inlet of wherever that air is coming in from, right? So that's the challenge of looking at all of the applications to say, is there one best way to do this versus designing it specific to what is either being driven based on your code requirements or maybe even your needs as well. I'm probably not answering the question here, but it's a tough one to get into.
Well, and I think that the answer is, it sounds like it's subjective, right? There's not one easy answer. So that's perfectly what we were looking for. So, and I suspect this will be another one. There's a lot of conversation that's been going on, and I'm trying to just draw out some of it here to bring to the forefront about sort of the interplay of the ASHRAE 62.2. And for those of you who don't speak ASHRAE nerd talk, we need fresh air in our home and we need to be able to calculate it. So basically these numbers, they tell us how much fresh air we should be having. And every year they have a new standard and there's new information. So we're always learning in building science, which is fun. We don't always know the answers and we learn new ones, but whatever standard, whatever 62.2 standard it is, some people are saying, well, bringing in all this additional fresh air per the standard is, harming our humidity, right? It's increasing humidity. So, perhaps ASHRAE has it wrong. So what do you say when you're trying to have that conversation about sort of what the standard says versus not causing a humidity problem, and when to bring in these systems? And also, let's bring in the ERV conversation, right? Because ultimately we're using that ERV to bring in that additional fresh air, and they claim to dehumidify, But, what kind of calculations or tools are out there to help people make sense of this?
Going back to the conversation of the baseline of ASHRAE 62.2, remember, that's the minimum code requirement. So even if there is a opinion based on that it's too much, that's the minimum requirement. I know that there's some that even go above and beyond and exceed that. And when we think about what does the fresh air provide to our homes, it's based on the industry studying this, it's the best single pronged solution right now. So if that's what the industry is stating that we need to do, understanding the dilution factor, the air replacement factor, but having the right system that can do that and not impact the condition of our home or even impact our equipment to have to offset that, that's where I always get the question, what's the best ventilation solution? And I'm never going to say that there is one. A lot of people will say, no, you're wrong, Chris, it's an ERV, it's an HRV. I would debate that, because do we really need to have an ERV and HRV in most cases? Passive homes, when we get into those ultra tight homes, yeah, there's no debate about that. We don't have enough capacity in whether we use a ventilating, and I mean, I have seen guys use ventilating dehumidifiers because the HVAC equipment is so small because of the load requirement, it can't offset that. So it goes back to the design. When we get into the design of our homes today, more energy efficient, green built homes, in creating that complete conditioned environment, and then driving the equipment selections based on those needs. Because if we stay focused in on, I'm in a high climate zone, well, hot, humid climate zone, I don't want to bring fresh air in, you're just hurting the occupants of that home. Let's design the system around what is best. And then the ERV discussion of how does that ERV really provide a true solution for dehumidification? Well, we have to remember the process of high and going to low. Is it truly a dedicated dehumidifier? No. And in some cases, I know that there's homes that are being tested today that have ERVs and dehumidifiers working in conjunction with one another in Houston, Texas specifically. So let's think about the opportunity that we have and design the best system that is needed for regionality, for what we're driving towards, and all of the above of creating a healthier environment.
There were some conversations here about a little bit beyond this, but maybe the ventilating dehumidification strategy can work. Maybe it can't. But, the conversation going on was about, this move to start using whole house ventilation systems, energy recovery ventilators, HRVs, to also serve as the bath fan and maybe even serve as the range ventilation for all sorts of various reasons, cutting costs and just having one nice system in place. Do dehumidifier systems or ventilating dehumidifier systems have the ability to do that? Have you seen anything like that?
Do you mean more of like a balanced type setup where we have an intake and exhaust to that? Or are you talking about bringing in the bathroom fans into the dehumidifier, the exhaust hood, and so forth?
Yeah, I guess it could be both. And the more I thought about what I said out loud, obviously these are supply systems and the other systems are really exhaust. So but I guess just kind of talk to that issue briefly, because there just was a lot of chatter about it. And I wasn't sure this is what specifically the right place for that conversation, but not sure if something like that can assist here. So,
well, I love the conversations around ventilation today. And in my previous role with April Air, I lived that quite a bit. And that's the opportunity as an industry that we all have to continue to educate one another, to get better and understand this, versus either voicing a opinion on why that strategy can't do or can do what it should do. And I like to keep it real and bring the field perspective. And when I was down in the Savannah, Georgia market, I saw a lot of ERVs going in, and it blew my mind. And I'm thinking, man, why So I'd start asking those questions. Why are we using ERVs? And to your point,
Mm.
Brett, it was, if we continue to use a bathroom fan, as it exhausts, the problem wasn't so much that the bathroom fan didn't work. It was the fact that when you have that much amount of moisture, that hot, humid air is actually just migrating through that duct, trying to make its way into the home to that cooler, drier air. It was condensing inside that pipe. It was starting to condense on the grill, and it started to deteriorate the drywall right around the bathroom fan. So you can either do one of two things. You could put a mechanical damper on the inset of where that pipe's coming in, but then you have to have access to it based on code requirements, and then you got a power consuming. So that didn't make a whole lot of sense. So now Energy Raiders and others are doing a fantastic recommendation of, hey, let's use our ERVs as a means of, this is where we're exhausting, that ERV is bringing that air in, fresh air from the inside. It's taking it and distributing it in. And then our exhaust is really from those areas. And there's nothing I could say that would state anything different in that application, because it's a great process of thought. The only a question I would have, if I was specifically thinking about what we've discussed today in the moisture content, is great. We got that solution. We got fresh air. We've got our bathroom fans. We got all that. We're good. What's the moisture level in the house? Is that acceptable in creating that healthier environment? And if the answer is yes, 2 thumbs up, man. Great job. Let's keep it rolling. If the problem is, well, no, man, we're seeing 58, 60, 65% relative humidity. Now we need to build on top of that system that they have and add into the further depth of the environment.
Great, thanks. And there was a question here about, since we have you, let's get to it. Do you have a little bit more time to hang out?
Yes, sir.
Yeah, great. Well, by one of our friends down in Phoenix, who, as you had shown, concern about it being too dry, of course. And so for those of you who don't know, we had Chris on just a little while ago, and I'm posting a link there, to talk about humidification strategies several months ago, as we were heading into the winter, heading into a third surge of COVID, which we understand being too dry might exacerbate COVID. And we're seeing that happening again, but thankfully it's getting humid. So, but for those of you maybe in areas where it's warm but dry all the time, the specific question to this was, do you recommend humidification even in like warm areas where it's dry to increase comfort?
I do. In fact, if we start to peel that back a little bit, it's exactly the opposite of what we just talked about in that specific market. And the opportunity to, we still have to cool, there's no question about it, right? In Phoenix, Arizona, we have to cool the air, but we have to think about that low humidity already. Our air conditioners are pretty darn efficient in what they're doing, but we don't have that moisture element. So we have to add in the moisture element at that point versus remove it. So I would 100%, in fact, steam humidification is probably the top rated solution in that Phoenix market or that Arizona market for maximum performance and maximum output to work with the air conditioning systems.
Great, thanks. Now, I want to preface this by saying this next kind of question or larger question or thought by saying, we absolutely, to help people become healthier, to help them become more comfortable, and to decarbonize our economy, we need all of our heating and cooling contractors. We need all of our mechanical engineers. But on the flip side, what we're finding is that a lot of the work that's being done is making it very difficult. The current work that's being done, and there's all sorts of reasons, is making it very difficult to do this. And we're finding a lot of struggles in our green building projects and others. And so there was a lot of conversation here, again, just about how HVAC contractors, mechanical contractors in certain areas, none of them understand this. And these are broad statements that are always made. And I make them too. So I don't mean to, I mean to say that what we need is workforce development for everybody. And so with that question, Chris, what is going on with you all? What are you seeing? What are you doing to help with training and awareness and understanding around humidity control for our heating and cooling contractors who we really need to support this work?
No, and thank you for bringing that up, because this is the opportunity we have collectively as an industry. And there are some really fantastic trainers out there that are lifting up the industry to at least get the understanding of this building environment that we all live in today. The industry has changed a lot from the days I was turning wrenches in the field to what it is now. But we have to invest in the time to want to get better. And Aprilaire, as a manufacturer, we spend a lot of time with our contractors and helping them and educating them. But there becomes this proactive, reactive approach in the field of, if the consumers are more aware of the opportunities, they will drive the contractors. But then, to your point, well, the contractors don't have a good understanding to it. So there's a confidence loss. So my recommendation would be, contractors need to invest in themselves and their people to get in devote the time to training. And I know there's a lot of them out there to do that. So thank you if you're on and you're doing that. If you're not, get a hold of the major manufacturers that you do business with and ask about a training platform that they might be able to do. Aprilaire, in one of my pleasures now in my new role, is we're building an academy. We're building a Aprilaire Academy where we're going to take every key element to the indoor environment, and we're going to start building curriculums and content behind it so we can align with folks like you, Brett, and others out there in the building science world, and bringing that into the heating and air conditioning industry. Because you're right, it's this kind of this, who's leading who in some cases. The builders don't know what they're talking about. No, your contractor doesn't know what they're talking about. And it's this battle. We should all be aligned and be at a higher level together.
Great. Thank you, Chris. Couple more technical questions here. And it's also great to see some of our HVAC 2.0, I think they call it the HVAC 2.0 Army, is joined us. And so it's always great to see folks from them hanging out here on our platform. But anyway, so there were some specific questions about does the unit efficiency PPM increase with cooler air or warmer air? Looking how to understand where it's most efficient to install the unit, example before or after the HRV intake. So we kind of answered that a little bit, but that was a more specific question. So
yeah, looking at it, the inlet temperature of where we're bringing that air in will ultimately drive the capacity of a dehumidification system and how much moisture it has the capability of removing from it. So that's where I would look at and say, from a calculation standpoint, your design is what's the potential incoming design conditions versus what our expectations are leaving that dehumidification system.
And then specific to the standalone ones, not the portable ones, but the standalone ones, thinking through placement on those. And, this specific question here was those who, have slab on grade and also don't have an attic. So there's very few places to put it. They're just wondering where a best place to put those are, should they be near exterior, interior walls? Anything you can speak to that?
Yeah, that gets the challenging, right? Because at the end of the day, these are not itty bitty small units either. They're
right.
And I will tell you, there's mechanical closets, multifamily mechanical closets that you can get a little strategic in, and it does take some redesign. We've worked on some projects in doing that too, and ultimately we want to just get the best area, the most volume of air from the space in and out of that unit. So if we were to put that in that closet, it might just be best that we utilize the HVAC blower in conjunction with the dehumidifier and look at the ducting options as well, so we can distribute that air more equally through the whole home. Other than that, you would have to consider this as more of a freestanding application where you can add a little bit of duct to it, but then you're talking about building walls and soffits, and it might get a little out of hand at that point.
When I think mechanical closet, I think of the heat pump water heater, problem getting shoved in the closet and then they just can't breathe, right? There's no air. So is that the same issue here where you need, if it is a closet, I know they recommend building in like louvers, or if there is a supply or return directly into the HVAC in that closet, is that sufficient?
Sure. Yeah, we definitely need the air, Brett. We don't want to have it as a sealed door and shut the door and this thing's going to use. So we definitely need air in and air out, whether we use a dedicated inlet and outlet through the dehumidifier to the space, or to your point, we use the HVAC ductwork.
I guess there was a specific question here if does the dehumidification process via the condenser, though that would probably then be talking about the heat pump. But I guess, can dehumidification help flush PM 2.5 from the air in general? Have you seen anything like that?
We're in the process of really looking at the ramifications of all measurements and how temperature and humidity all play a factor into the relation. I know I don't have anything specific that I can share that I've seen the reduction of PM 2.5 specifically in relation to it, but we are in the process of studying all that within our company.
Have you seen any dehumidification systems that use an outdoor air relative humidity monitor and act in accordance with what they're seeing based on outdoor air at all?
You mean if the outdoor conditions are, say, too hot, too humid, we don't call for the ventilation sequence?
Yeah, I mean that specifically, or it could go the other way, but yeah, exactly. Yeah. So that it's taking into consideration what's happening outside as well as inside. Yeah, no, we have the control logic that we can utilize in using sensors outside that would either, if it is too hot and we don't want a ventilator, we don't want to dehumidify, that we could shut it off at that point. Yeah. Gotcha. Well, Chris, we are way over our time here, and those are the majority of the kind of general questions I saw, and we'll send you all the other questions so you can respond if you'd like. But thank you so much for joining us again. Thanks so much for April Air for giving the time to do this and all the support. Where can people go to either contact you or contact April Air, or just learn more about everything you're talking about here? Sure, we've got a lot of great resources. You can go to aprilairpartners.com. That's a really great informational site that we have available. You can also download an app. We have the April Air Healthy Home app that also has a lot of great information that's embedded in there. You can also reach out to customer service at 1-800-334-6011, and they can get you connected with anything that you might need there as well. Great, Chris. Thank you so much for your time. Good to see you out there again. Thank you all for joining us. We'll see you next week. Take care. Be safe. Be well. Bye. Thank you, everybody. Appreciate y'all.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.